Who here has heard of AZTEC and who has kind of tried to use it in the past? Adjust accordingly. While we're waiting, the best holders can also join our Discord server. There's a lot of tips and tricks in there.
Cool. All right, so we're going to get started. So welcome to AZTEC's Developer Workshop. We're going to kick off basically just with our Discord server, so if you need any help throughout the weekend, we're going to be available on Discord throughout. So just scan our QR code and head to the channel, post any questions you got there, and we'll be over to help. So if we just start off with what are we doing at this hackathon this weekend? So we've got two bounties. So we've got $1,000 for the best use of AZTEC in any dApp. And then our second prize is for the best use of AZTEC in a novel fintech or DeFi application. And to help you realize these goals this weekend, so we've got Joe, who's our head of product, and we've got myself, who's an engineer at AZTEC. So cool. So what is AZTEC? Well, just before we get into that, why is privacy important? So AZTEC is a privacy solution. And why do we think privacy is important? Well, there's a few different reasons. So first of all, traditional financial assets need privacy, and they offer it by default. We think it's a prerequisite for building some of these assets on-chain. And lastly, it allows third parties users to control third-party access to financial and personal data. So with this in mind, what is AZTEC? So AZTEC is an interoperable privacy network running on Ethereum. We have a toolbox of different zero-knowledge proofs that allow you to build privacy to your dApps with custom logic. We are extremely gas efficient. To do a standard private send transaction, so for me to transfer private value from person A to person B, currently costs about 800,000 gas using AZTEC, and EIP 1108 is going to be merged in the next Istanbul hard fork, and that will bring it down to about 200,000 gas. Another really important thing to consider when you're using zero-knowledge proofs and looking at these privacy technologies is how long they take to construct a proof. So with AZTEC you can do it in milliseconds, even on an Android phone in browser, which is quite important. So if we just move on, so the AZTEC toolkit, so AZTEC is, you can think of it as a family of zero-knowledge proofs. Each type of proof allows you to do a different type of business logic. So you've got things like send, swap, you can swap confidential assets. You can calculate interest rates on zero-knowledge assets, so you can stream interest in zero-knowledge, and we've got a demonstration that Joe might talk through later on about something called our loan dApp, which does exactly this. You can mint directly these zero-knowledge assets, burn them, and you can construct inequalities over them. So you can say that zero-knowledge asset A is greater than zero-knowledge asset B, for example. Things like that. So that's our toolkit. So what can you build with AZTEC? So there's various different things, and these are just some ideas to maybe get you started. So security token platforms, loans, bonds, you can make all of these confidential using AZTEC. There's been previous hackathons where people have done quite well integrating AZTEC solutions into these type of assets. You can build decentralized private payment services, and there's an example there combining AZTEC with some sort of sidechain to give you private Venmo. got DeFi applications, and but we're more excited really about what you guys are going to build and the creativity that you guys will bring to AZTEC this weekend. Cool. So with that, I think Joe's going to take over and give you some demos of our kits.
Yeah, so we'll do two things. Just a quick demo of what we built with AZTEC to kind of give you like a kitchen sink of what's possible, and then we have a kind of starter kit for everyone to kind of download and clone that uses our developer extension that will help you kind of get started and be like an entry point for your coding this weekend, hopefully. So without further ado, so this is So this is our what we call our loan app. It's really just a kitchen sink example of what you can build with AZTEC. It uses the send proof, the swap proof, the dividend proof, and one of the range proofs. So all the code is on our GitHub. You can clone this. It's a good starting point for kind of viewing how to use all the proofs in contracts, and also some of the front end proof construction code. So I'll talk you through this. The first thing we're going to do, the purpose of this DApp is to create a private loan. We're going to create a loan where the notional is private. So we've got 100,000 notional of DAI with, I think, interest rates about 22% at the moment. And we'll have a very short loan, so it matures in this workshop. So as you can see here, we can create the loan very fast. In that moment, we've used the mint proof to mint the zero-knowledge asset, where there's one note worth 100,000. On the right-hand side, we are the lender, so we can see the encrypted balance of the loan. We can decrypt the AZTEC note and reveal its hidden value. On the left-hand side, we're a potential borrower, and we can't currently see the encrypted value, but we can see the public variables which describe the loan metrics. We could also make some of these private if we wanted to, but in this example, just the notion is private. So the next step is to view one of the loans that is available here. So a lender can decide to submit a view request to one of these loans. Let's get to this. You now see there's one view request here, which we can decide to approve that particular borrower. And as that happens, the loan will move into approved loans, and this borrower can now decrypt the hidden value and see the notion of 100,000. The next step is to then settle the loan. So in this instance, we're going to settle the loan by swapping 100,000 zero-knowledge DAI for 100,000 units of the loan notional. The loan can later be traded if you wanted to, much like the secondary market for loans today. So when we press settle here, we're first going to give ourselves some fake settlement currency, this is a test app, and then we're going to swap that currency in zero-knowledge form for the loan notional. This is constructing the proofs in the browser, and here you'll see that the loan's just been settled. And the really cool thing about AZTEC is it means that you can now stream interest out of that loan in real time. So as you can see, both of these now have a ticker, which is the interest that's currently accrued or the interest that's currently owed. So the borrower here can now decide to withdraw the currently accrued interest in real time using our dividend proof. So we can see here that they're using a combination of proofs. Slight quirks of solidity mean that you have to use whole seconds, which means the integer arithmetic sometimes doesn't work, so the amount has to change. But you can withdraw a certain amount of DAI in real time from the loan. Another interesting thing about this is if the lender decides to withdraw the entire loan amount, like so, as interest accrues, the loan will now risk going into default. There's now not enough collateral stored in the loan. All of this is happening with zero knowledge to make the loan be in good standing, and we can use a series of proofs to actually mark the loan as default and potentially move collateral from the lender held on behalf of the smart contract to the borrower. We call this programmatic default. So instead of in the old world, you'd have to go to court, say the loan's in default, and then fight for that collateral to be transferred. In the smart contract world, you can actually prove on chain in zero knowledge that there's not enough collateral in the account, and any collateral associated with this could then be released by the smart contract to the borrower. So we can do that here. As proofs validated, the loan is now in default. If there was any collateral, the smart contract could have moved the collateral. So this is really just a kind of a kitchen sink example of what you can do. We're not expecting kind of this much functionality this weekend, but it's a good place to kind of get some ideas of what's possible as you combine different sets of proofs. The great thing about the toolkit is you can layer the proofs with as many layers as you want to get the functionality that you need. So the next step, I think, is to quit these and get everyone to download the ETHGlobal stuff. So if you head to our GitHub, there is a repo, if everyone can join that would be great.
The Ganache starter kit?
There's an ETHGlobal starter kit. The Ganache starter kit's also really useful if you're just doing smart contract work. So the ETHGlobal starter kit also has our developer extension, which I'll talk through in a second. Cool. So when you get this running, you should get a page that looks a little bit like this. There are some docs. If you click this link, it will take you to a GitHub page. It gives you some of the details developer extension. Before we get started, it's probably worth me just running through why we have this developer extension and kind of its point. So under the hood, AZTEC represents value as nodes in a UTXO model. So it's much like Bitcoin. You have a balance, say 100 units, you store it in a node, and when you send it, you end up splitting that node into multiple new nodes, or storing the old nodes. This means that it becomes quite hard to keep track of these nodes and their associated viewing keys that allow you to decrypt the values. This would be solvable if certain EIPs have been passed by MetaMask, which I haven't currently. So we built a developer extension while we're waiting for those EIPs to be passed that keep track of all the users' nodes, their associated viewing keys, and make it much easier for developers to interact with AZTEC. So all the extension does is store two keys, a public key and a private key. It doesn't own the assets, it just allows you to decrypt the value of an AZTEC node. The nodes are still owned by MetaMask or whatever Web3 provider you decide to use. And then the extension injects into the page an AZTEC object on the window, which exposes a set of APIs. This is just a subset here for the demo, but the documentation here lists all of them here. So let's just talk through what this does. when you enable AZTEC, the first thing it will ask you to do is create the keys and the password, and then you'll be asked to link those keys to MetaMask. If you want to use a different wallet here, you just need to configure AZTEC enable with a different provider. So this is just a EIP 712 signature to link your MetaMask account to the keys that we're storing inside the extension. So we'll sign this and send it to the local. Oh, 1 second. Joys of MetaMask. A little refresh on the There we go. So once you've done that, every time a page requests access to a particular asset, the extension will pop up. This is very much an alpha extension right now. The UI is going to improve before our mainnet launch, but it will pop up saying what the domain is and what asset it's requesting access to. So once you've approved that, still loading over here. What we're going to do here, though, is we're going to use the AZTEC extension to deposit some ERC20 tokens into AZTEC note form, and then we're going to send some of those tokens around to another MetaMask account. And what we're going to see is that the extension will enable the web page in both cases to have real-time access to a user's balances and zero knowledge. So it's just injecting into the page for any given asset, user's balance through the window object. So let's just check this as we started. Just go and remove the extension. I'm not sure what's happened here. Well, I will keep trying to do this, but has everyone got to this stage? I've got a working kind of a working web browser, and then the graph package started. Because that didn't work, we'll go to our backup plan, which is the simpler version of this, which is the same demo we've just done through truffle tests. So we also have this Ganache starter kit, which does exactly the same thing. It deploys the same AZTEC assets, but instead of the code being run through MetaMask, it's just run through truffle. So let's try this really quick. happen to be the global start kit for push and fix, but I think it's just my internet connection.